Welcome to day 70. Today, we're talking about one of the most important parts of building an NLP model, figuring out if it's actually working. Let's get into evaluation metrics. So, picture this. You've just trained a model, and the dashboard is glowing. 99% accuracy. That's fantastic, right? Time to ship it. But what if I told you that number might be hiding a massive failure? By the end of this, you're going to understand exactly why high accuracy can be misleading and, more importantly, how to pick the right metric for the job. This brings us to a really common problem that I like to call the accuracy trap. It's that false sense of security you get from looking at just one big, shiny number. Let's make this real. Imagine we're building a system to detect hate speech. Its number one job is to find and flag comments that are negative. Here, you can see the ground truth, what's actually correct, and what our model predicted. As you can see, it perfectly identified the two negative comments, but it got the others wrong. Now, if we calculate the overall accuracy, just the total number of correct guesses, our model scores a pretty awful 20%. Looks like a total disaster. But hold on, what was our main goal? To find the hate speech. And on that front, our model was perfect. It found 100% of the negative comments. This is the accuracy trap, right here. That low overall score completely hides the fact that the model succeeded at its most critical task. Okay, so this shows us that overall accuracy is just too blunt of a tool. We need to ask better, more specific questions to understand what our model is actually doing. There are really two sides to being correct. The first question we should ask is about completeness. Of all the actual hate speech comments that existed in our data, how many did our model successfully find? Did we let anything important slip through the cracks? In machine learning, there's a name for this. It's called recall. A high recall means your model is doing a great job of finding all the things it's supposed to find. It's comprehensive. But there's a flip side, isn't there? When our model did flag a comment, how often was it actually correct? We can't just have a system that raises false alarms all the time. And that idea is called precision. High precision means that when your model says something is hate speech, you can trust it. It's not crying wolf. It's exact. Now here's the tricky part. Precision and recall are often fighting against each other. If you make a model that flags almost everything, you'll get perfect recall, right? You'll catch everything. But your precision will be terrible because of all the false alarms. We need to find a balance. And that's exactly what the F1 score is for. It's a clever way to combine precision and recall into a single number. It's a harmonic mean, which basically means it heavily punishes a model if it's bad at either precision or recall. To get a high F1 score, you have to be good at both. This whole balancing act isn't just for simple classification. It's just as important for more complex, creative tasks like machine translation or automatically summarizing an article, where there isn't just one single correct answer. For those jobs, we use specialized metrics. For translation, there's BLUE, which acts a lot like precision. It checks if the words the model chose are good ones. For summarization, there's ROUGE, which is more like recall. It checks if the summary captured all the key points. They're just different flavors of the same core ideas we've been talking about. So why does all this matter in the real world? Well, because choosing the right metric is how you make good decisions. It's how you compare different models, how you fine-tune them, and ultimately, how you build a system that you can actually trust to do its job properly. Let's make it even more concrete. For credit card fraud detection, you would rather have a few false alarms than miss a single actual case of fraud, right? That's a high recall problem. But for your email spam filter, you'd rather let a few spam emails through than have an important email from your boss get hidden. That's a high precision problem. The metric has to match what's at stake. And that's really the bottom line. There is no single best metric. The first step is always to think carefully about what success actually looks like for your specific problem. So the next time you start a project, just ask yourself this one simple question. What's the cost of a mistake? Is it worse to miss something important, or is it worse to flag something incorrectly? Your answer to that question will tell you everything you need to know about choosing the right metric.